So you click play, you hit send, you add something to your cart, and then you wait, right? That tiny, sometimes super frustrating pause between your action and, well, the result. It feels like magic, or maybe it just feels like a total mystery. But what if I told you it's actually an epic journey? Okay, let's dive into the secret life of a single data packet.
No, really, have you ever actually stopped to think about it? When you click a button on a website, you're not just poking at your screen. You are literally launching a messenger on an incredible, high-speed quest across the globe and back again. All of it happening in the blink of an eye.
So for this explainer, let's frame this whole thing as a hero's journey. Our hero? A tiny packet of data. And its mission is to carry your command to some distant server and then return with the prize. The technical term for how long that entire mission takes? Well, that's what we call latency.
To really get a feel for this, just imagine the internet is a giant system of water pipes. Now, latency isn't about how much water is flowing through, that's bandwidth. No, latency is all about the time it takes for one single drop of water to travel all the way to the end of the pipe and for you to get confirmation that it actually arrived. It's all about that round-trip speed.
Okay, so let's actually map out this quest. We're going to follow our little data packet on a super common mission, the simple act of adding an item to your online shopping cart.
The second you click that button, the clock starts. Our packet hero is sent out from your browser with a clear message. Hey, add this item. It travels all the way to the server, which reads the message, does its thing. Maybe it checks the inventory, updates your profile, and then it sends a confirmation packet all the way back. And boom, mission complete. The item pops up in your cart. That entire round trip is what we're talking about.
And that brings us to the formal definition. Latency, which you'll also hear called round-trip time or RTT, is just the total time it takes for that journey. Simple as that. The lower the latency, the faster and more responsive a website feels. And this matters. It really matters. There are studies that show a delay of just 100 milliseconds, literally the blink of an eye, can cause conversion rates on e-commerce sites to drop by up to 7%. That's huge.
Of course, no hero's journey is that easy, right? It's always got to have some obstacles. Our data packet doesn't just travel on a perfectly clear, straight road. Nope. It has to navigate this complex obstacle course, and it's filled with villains and challenges that are constantly trying to slow it down. And here they are, the main culprits. You've got the sheer physical distance of the Great Divide, a whole series of toll booths it has to get through, and these slow archives it might need to dig through on the server. So let's break these down.
First up, we've got propagation delay, or what we're calling the Great Divide. And this one is just pure physics. Data travels incredibly fast. Yeah, it's near the speed of light through fiber optic cables. But here's the thing, it's not instantaneous. If the server is on the other side of the planet, that distance alone adds a delay that no amount of fancy code is ever going to eliminate.
Next, our hero runs into the toll booths. You see, the internet isn't just one direct line, it's a massive network of networks. Your packet has to hop between maybe dozens of different routers to get where it's going, and each router has to stop the packet for just a split second to read its address and figure out where to send it next. One toll booth is no big deal, but when you have dozens of them, it really starts to add up.
And then we've got the archives. So once our packet finally arrives, the server might need to pull some information from a database or a storage system. Now, if that system is using an old, spinning hard drive, it's kind of like asking a librarian to find one book in a massive, totally disorganized library. But a modern solid-state drive, an SSD, that's like a librarian with a perfect digital catalog. It's way, way faster. So, with all these potential bad guys on the road, how do engineers figure out exactly where our little hero is getting stuck? They can't just guess. They need to scout the entire route, and to do that, they have a special set of tools.
So, engineers have three main tools for this. Think of ping as just a simple stopwatch. It tells you the total mission time, but it doesn't tell you where the delay has happened. Then you have traceroute, which is more like a GPS with traffic alerts. It shows you exactly how much time each individual hop took, so you can see which toll booth is causing the traffic jam. And finally, MTR basically combines the two, giving you this continuous live mission report on the entire journey. Pretty cool.
Okay, so once the bottlenecks are found, it's time to equip our hero for success. This is where the real magic of web optimization comes in. Engineers have this whole toolkit of power-ups they can use to make that packet's journey faster, smoother, and just way more efficient.
Now, one of the most powerful tools in the box is the Content Delivery Network, or CDN. So instead of making our packet hero travel all the way across the Great Divide to the main server, a CDN keeps a copy of the website's content in servers all over the world. Your request just has to go to the closest one. It is the ultimate shortcut.
But that is not all. Using something called HTTP/2 is like turning a single-lane road into a multi-lane superhighway, letting tons of packets travel all at once. Browser caching is even better. That's like our hero realizing it already has what it needs and doesn't even have to make the trip. And of course, writing really efficient code on the server and using things like asynchronous programming makes sure that once our hero arrives, it doesn't get stuck waiting in line behind some other, slower tasks.
So here's the real takeaway, the crucial point. You can't completely eliminate latency. It's just not possible. The laws of physics, the complexity of the internet, they make a truly zero latency system impossible. But you can always optimize it. You can always help make that hero's journey just a little bit faster.
You know, every single millisecond you save makes for a better experience. And that opens up brand new possibilities for everything from online gaming to global communication. The quest for lower latency, it really is never ending. And now that you understand the journey our little packet hero takes with every single click, the only question left is, what are you going to do with that knowledge?